Hey everyone, welcome back. Today we've got a more spontaneous episode for you. I just received a SPARCstation 10 and I wanted to walk you through the checkout and first boot process for it. Let's get started first with just the initial checkout and the overview before we even get into the booting. So I always record an unboxing video really just for proof for shipping damage. If I was a shipper and someone called me up and said there was a problem, I'd love to have proof to know that it was the shipping company that damaged it. So this shipper did an amazing job, box within a box, a bunch of cotton padding, extremely happy with it. Up next we've got the case itself. It's got a few nicks and scratches on the front of it. There's quite a bit of yellowing. The feet have gone from kind of a purple to a yellow color. But overall the case is, I would say, in good to excellent condition. Serial number shows it was made in 1993. We'll talk about serial numbers a little bit more in a bit. But you can see the big vent on the left hand side of the screen there. Airflow and cooling in the SPARCstation 10 is pretty necessary due to how hot the processors and some of the ASICs run. Let's do a bit of a walkthrough through the back panel here. We've got an IC power monitor, dual BRI connectors. They come with these plugs in them. You can unscrew them, but best to leave them plugged up. There's these two micro connectors. One's a micro parallel port, another's a combined audio and AUI port. You need special cables to use it. There's next to that, standard Sun keyboard. This is a 25-pin dual port serial. There's one port, but you need a breakout cable. Standard Ethernet RJ45 SCSI, and there's a blank, as this is not the SPARCstation 10 SX that has the onboard video. You can see there's a 13W3 from the video card, and then we've got the cable lock slot. So in order to get into the case, you've got to unscrew this cable block, and it comes out, and you can see there's a hole in it. You'd run a cable through that, which would prevent anyone from unscrewing the case, and also prevent them from removing the case. That other big screw is kind of a thumb screw. You can get your finger in behind there, but you really need a screwdriver to get it out. And a sharp tug sort of brings the top of the case off. Inside of the case is in great condition. All the plastic is intact. There's a little bit of dust on the inside. You can see the big EMI shield, but extremely happy with this so far. So we'll take a bit of a closer look inside the case now. Got a floppy drive up there in the top left-hand corner, and there's our hard drive. This case was still really cold. It had been on the porch. Got a SCSI connector and some very complex braiding of the SCSI cable for another internal hard drive. And you can just slide the hard drive towards the back of the case and it pops out. It's got these 4 rubber feet. And surprisingly, this is an ancient digital SCSI drive. I haven't seen one of these in a really long time. We'll go into that in a little more detail later, not too much. And then we've got 4 RAM sticks that it came with. And there's 8 slots for RAM. And there's 4 of these S-Bus connectors. You sort of stack them on top of each other. This was new in the SPARCstation 10. We've got a Sun GX video card. We'll look at that in a little bit more detail later. And then there's the processor. It's on a bus called the M bus. And it's just a single processor, and there's actually no cache. We've got 3 big fans in the power supply, and the fans cool from the left of the screen to the right of the screen to blow cold air over the CPUs and the ASIC underneath it. We've got these plastic standoffs. They kind of move forward and they clip the S-Bus cards in place. And then there's a big sort of complex floppy drive and SCSI connector there in the top right hand corner. These RAM slots are really nice. They've got levers on them. We'll look at them a little more later. And now we're going to take on one of these cards. So these S-Bus cards are a little bit different than in the prior generation. SPARCstation 2, SPARCstation 1 Plus, and they need these sort of tabs to hold them in place. The cards are a little bit shorter, and it's really just a matter of undoing these 2 screws to get these small little metal tabs off. And then the card is basically just as easy as sort of pulling it out of the case from usually the back part of the card. You need to loosen up these 2 plastic sort of stands at the back of the card to be able to pull the card up. There we go. And then just gently levering the card up, and you can see the big Sun GX ASIC on it, the 2 clock chips, 2 crystals rather, and a bunch of RAM. And if you're ever looking for a Sun part number on S-Bus and M-Bus modules, it's usually there on the back of the connector on that white sticker. And what we're going to do next is we'll pop out the M-Bus module itself. I don't actually have to do this. You can usually just pull the M-Bus module up and out from the inside of the case, but these sometimes can make it a little bit easier, and I'm just trying to be super careful here to try and in sort of getting all these parts out. Mechanically, these plastics are pretty old and they can break pretty easily. So just a better look at the CPU module itself. It's pretty small, big single CPU, and then just supporting electronics and a fuse on it. And you can see the M-Bus connector there. And the part number for this module, it's so old, is actually on the top of the module itself. So let's go through a bit of a walkthrough of the motherboard components here. Focusing on the bottom half of the board first, where the majority of the ICs are. Up here in the top right hand corner, we've got an Intel floppy drive controller. And next to it with the orange sticker is the famous SGS Thompson battery backed up NVRAM and time of day real-time clock. These are famous for having the batteries die, and there's a bit of a process to repair and restore them. Hopefully I'm going to make a video about that to explain that in a bit more detail. Below that is a TI-27C040 EEPROM. This is really what stores the BIOS, or what's called the Open Boot PROM in Suns. Next to that, we've got a 10 megabit per second fast SCSI controller, the FAS101. Then the ubiquitous AMD Lance Ethernet controller. Up next, there's 2 AMD serial communications controllers. One of these controls the dual serial ports accessible on the back of the computer, and the other one is for the standard Sun keyboard and mouse. Here we've got a custom ASIC from AT&T and Sun, and this is the ISDN controller. Up there, rather down at the bottom here, you can see the JTAG test block. Then zooming out a little bit, up next, immediately adjacent to the RAM sockets, is a massive ASIC. This is the EMC ASIC, the ECC memory controller. Below that, wearing a big heatsink, is the MSI ASIC. This is the M-Bus to S-Bus interface, or what connects the processors essentially to the rest of the system. Then here, centrally in the bottom part of the board, you can see the SEC ASIC. This is the S-Bus to 8-bit bus. Basically, this motherboard essentially has 2 S-Bus cards on it. One of the S-Bus cards is the 8-bit card to control all the slow stuff, the floppy, the serial ports, the keyboards, mouse, the NVRAM, the PROM, and this basically is the S-Bus interface ASIC for that. Right next to it, we've got a direct memory access ASIC for the faster stuff on the motherboard, for the SCSI port, for the Ethernet port. And yeah, that's basically a quick walkthrough of the major components on the motherboard. So one of the best sources of data that I've found about the SPARCstation 10 has been this white paper, which I found online, SPARCstation 10 System Architecture. It's been just awesome at explaining how this whole thing works. It's got a great comparison of the SPARCstation 10 Model 30, which is what we've got here, to the SPARC 2 and the SPARC 1, which I have both of those. You can see even though it's running at 36 megahertz and doesn't even have a level 2 cache, it's almost twice as fast on SPEC Int92 and more than twice as fast on spec FP92 as the SPARCstation 2. It's also got some great architecture explanations. You can see here we've got the CPUs up here in the top left corner. They communicate via the M-Bus. The M-Bus is directly connected to the memory controller ASIC, that big chip next to the RAM slots. And then with the big chip underneath the CPUs that has the round silver heatsink on it, that's the MSI ASIC, and that communicates with the rest of the system here. You can see here's the big SEC ASIC with all the slow stuff connected to it, slow and quotation marks, and then the DMA2 controller with the Ethernet and SCSI hanging off of it, and you can see the 4 internal SBus slots as well. Down here you can see the audio is a little bit unique in this computer. If I had purchased this new, it would have come with a speaker box, and the speaker box really is what contains the digital audio codec ASIC, which has all the sort of line in, line out microphone headset connections to it. As it stands right now, without this speaker box, I think I'm just limited to an internal speaker. I don't even know if there is one. So there's almost no audio support right now on this computer without that speaker box. Anyway, just wanted to reveal my sources here. As always, Sun has pretty great documentation, but it's getting harder and harder to find. Okay, so enough background and overview. Let's get ready to power this one on here. So in buying vintage hardware, there's a lot of gotchas, and this is really where a little bit of planning can save you a lot of heartbreak if you're preventing you from turning power on at the wrong time or something. So let's make a list of all the stuff we should do before we power it on, and whether it's a SPARCstation or an old PC, a lot of this stuff still applies. First thing I want to do is I want to look up all the specs. I want to actually know what is in this computer. Sometimes you buy stuff and it's secondhand and it's sort of a parts bin special. It's been thrown together and parts can be incompatible. So I want to make sure that everything here sort of should actually work together, and to give me a bit of a better understanding of all the vintages of all the stuff. So I want to look at the PROM. Using the white sticker on the top of the PROM as a Sun part number, I can figure out what vintages it is and whether it's compatible with the processor that's in it. I want to look at least what kind of hard drive this is, how big it is, the motherboard revision. There's usually tons of motherboard revisions in these computers. I want to look at the processor, figure out what kind it is. I want to take a look at what size RAMs those are, make sure they're all the same, make sure the video card is going to work, and see if I can decode the serial number to find out where in the production run this one came from. Next, we'll disconnect the power supply from the motherboard and just at least do some testing on the pins of the power supply unit just to make sure that there's no voltages there that look like they don't belong. After we do that, we can, it's best to check the RAM configuration. Oftentimes when people sell old computers, they pop out a bunch of the RAM or they throw in a bunch of RAM, and it may not be in the right slots, and you can burn a ton of time at power up, saying, oh, getting weird errors or something like that. So we'll just make sure the RAM's in the right banks. Find a quick run through of the chips just to make sure the PROM or the NVRAM isn't backwards in its socket. Just don't want to power something up and have it burn out a chip because someone popped it out and popped it back in, not in the right way. We'll do an initial power on just with serial connectivity. If something's going to go bad, I don't want it to blow up the video card, so we'll just really power it on with keyboard and serial, and we can watch the debug scroll by on a laptop I'll have connected to it. And no real need for a hard drive at that point. I'm sure if the hard drive still works, I want to be able to potentially recover any useful data from it or get the old host ID off it, so I want to minimize wear and tear on that hard drive. It's pretty old. Then we can do a final power on if everything works and gets us to this point. So no different than if I was in Chem Lab. I'm just going to make some notes here about all the part numbers I've got, and then I can use this to go back and forth and reference them. And really this is just to keep myself organized. Sun's got a pretty good part numbering system. So if you're going to see me looking up a bunch of stuff here, where this all comes from, this is Sun System Handbook. You can just Google it. There's a few of these of different vintages available online, and they really have all the parts number and systems and component breakdowns, and they pretty much tell you everything that you needed to know about these systems. So we'll work bottom up from our list. First of all, I just want to get a look at this serial number. This is from the system handbook. This is the type of serial number we've got. We've got a year, week, plant code, and then build number. So looking at it, 323F2227. This tells me that this was built in 1993, 23rd week. We can look at the plant code here. It would have been Milpitas 4 in California. And so we'll add that in. And then the build code, I'm not sure what this means, but presumably there was multiple build or runs or whatever every week. So what we can do next is we're going to look up that graphics card, and I'm pretty sure it's a GX. And yeah, there it is, 501 1996. So it's just the standard GX. It is an accelerated frame buffer card, but nothing too special. No 3D or anything like that. Great. The RAM are these 501 2273s, and just Googling them tells me that these are 16 megabyte DIMMs. They're 200 pin DIMMs. And these are pretty cheap. I think these systems can take up to 64 megabyte DIMMs, and for a max of 512 megs of RAM. But right now, with 4 of these 16 meg DIMMs, we've got 64 megs of RAM in the computer. Now this is from something called the Rough Guide to MBus Modules. And you can just Google that, and it has all the different CPU modules for SPARCstation 10s and 20s and the SPARC servers that used MBus modules. And the one I've got is a Super SPARC 1. It's running at 36 megahertz, and it has no level 2 cache. Now there was a note in there about that, so I want to go back and take a look at that note. And this one tells me that this was an early revision of the MBus protocol, and this module actually does not support multiprocessing. So even if I wanted to get a second one of these modules and plugged it into the motherboard, I wouldn't have a multiprocessor system. It may or may not work. Probably not. So next up, there's a couple different stickers on the motherboard, and I wasn't sure which one was the right part number, but a quick search here in the SPARCstation 10 handbook basically shows me which motherboard this is. And yep, there it is. Or 501 1938. There, we can scroll down and find it. And it tells us which revision it is, and it does have support for the GT and ZX graphics options. Those are some of the more advanced 3D graphics cards graphics systems that Sun released. The ZX is a big internal board, and the GT or graphics tower is a big external tower. The support for those in later versions of Solaris is pretty limited. And it's not like they're going to make Quake run faster or something like that. They were pretty application specific. So anyway, this gives me a good idea what motherboard revision I'm using, and there were a few different motherboard revisions with different jumper layouts and things like that. So let's just update that for the right one. And now the hard drive I've got is a digital DSP3105. We'll come back to that in a second. Let me just, while I'm still in the Sun System Handbook, we'll look up the boot PROM. And that boot PROM revision 05 is the 2.12 with support for up to 2 of the SM40 modules. So it's sort of a mid-life PROM. It's not the earliest one released, but it's not the later one with support for the really fast HyperSpark modules or anything like that. So I should be able to get some blank PROMs if I don't already have some, and burn a new OBP for this. Finally, this disk drive, this is really all I could find about it. Just tells me it's a 1 gigabyte SCSI disk drive. And yeah, that's pretty much it for our sort of parts inventory here. This gives me a good layout, lets me know what I'm working with, and we've already found that everything looks like it should be compatible with each other. So moving on to the next step, what we're going to do is we're going to test out the power supply. So we've got this big connector back here, and it requires the usual sort of fiddling and pulling and tugging to get it off the motherboard. There is a clip, but even with quite a bit of pressure, it didn't sort of want to come off. And nothing special. I'm just going to take my multimeter, ground it on the power supply case, and essentially test all the voltages. Yeah, so just as I was prepping to get this ready here, I powered on and realized I hadn't disconnected the hard drive. So just wanted to do that. So as I pulled it out, though, I realized it has yellow barcode stickers on the bottom of it, or orange. So those look like it's probably a Sun part. Anyway, this is just very quickly stepping through the voltages, through grounding against the power supply, and then using the positive probe to basically stick it into the PSU connector. And really what I'm looking for is everything is 5 volts, minus 5 volts, minus 12 volts, or 12 volts, or pretty close there too, or 0 volts. It should be same as ground. So it was a pretty straightforward process. Didn't run into any surprises. Nothing looked like it was particularly out of whack here. So up next, I really want to check to make sure that the RAM's in the right configuration. My source here is the SPARCstation 10 service manual, and this is still available from Oracle, and you don't need to log in to download it. Chapter 8 is all about the DSIMs, and basically this has the layout of the system board, explains all the slot numbers, and it explains sort of what's a valid layout for the DSIMs and what isn't a valid layout. And so you can see here's the installation sequence. If you only got one, it goes in slot JO201. If you've got two, the second one goes in JO304. So there's really quite a bit of sort of hopping around throughout the RAM slots. But the sort of long and short of it is that the RAM should be in the first, third, fifth, and seventh slots. So moving the DIMMs around is really straightforward. While they're not metal clips, it's still pretty strong plastic, at least at this point. And there's these small levers on the end of the SIM sockets, and you push them away from the SIM that you want to move, and it sort of pops one edge out. You need to be pretty firm with them. You sort of pull them out, and they do make this sort of resounding or reassuring clunk when they're in socket. You can certainly run into issues here if you've never sort of put these SIMs in before and you don't know how much pressure to use, but there's a real positive sort of clunk when they're properly seated. Next, I really just wanted to take a look at the motherboard and make sure that the sort of two user replaceable chips were properly seated. The only two user replaceable chips on this motherboard are the NVRAM and the PROM. And there's a little notch at the end of the PROM, and there's a silkscreen notch on the motherboard. And the same thing goes for the NVRAM. Now, the NVRAM in the SPARCstation 10 has this nice plastic carrier. You can pull it out, and this is me sort of trying to pull it out. And then I remembered that these have a tendency, when you get your fingers underneath them and you really sort of pry them out, they come out all of a sudden and they tend to fly across the room. So not wanting to do that on video, knowing it wasn't the right orientation and not wanting to bend a pin, I figured I'd just leave it in for now. So up next, I wanted to go through the jumpers on the motherboard and make sure that, for example, the CPU is running at the right clock speed. So again, this is in the SPARCstation 10 service manual, and it's really straightforward. There's really only two sets of user configurable jumpers on this motherboard. One is for the serial ports. The serial ports can run in either RS-232 mode or RS-423 mode. However, I haven't actually run into a situation where this matters. I often use a null modem cable to connect these to another computer to look at the serial output, and it seems to run fine even in RS-423 mode, even though people tend to think of COM ports as being RS-232 devices. So, unless you're hooking this up to some kind of modem or something else, a router directly, I don't think you really need to worry about it too much. The other jumpers that I really want to take a look at are the clock speed jumpers. Now you can run the system clock and the M-bus clock at different rates depending on the CPU type that's in the machine. This is a Model 30. I've got a 36 megahertz CPU, and so you can see it should be in what's called jumper setting B. Now there were multiple revisions of this motherboard, but some are what were the 3 clock speed jumper versions, and some were the single clock speed jumper versions. So the rev of motherboard that I have is a single clock speed jumper motherboard, which is not this one, and so it's sort of further down, and the jumper was already in position B. Here it is. So there really wasn't anything for me to change. It looks like this system, other than the RAM being in the wrong slots, was pretty much already set up and good to go. So up next, we're just going to disconnect the mains from the power supply, plug the power supply back in, make sure our power switch is off, and that the connector is seated nicely on the motherboard. Up next, we're going to replace the CPU. We're going to at least need a CPU to boot. So we've got the M-bus module here, and they're a bit fussy to get in, to tell you the truth. There's these 2 sort of holes on the bottom of them, and they rest on these 2 little sort of metal nubbins on the inside of the case, and the connector is pretty fragile looking. In reality, I've never had a problem bending a pin or anything like that because the connector is keyed, but there's these large blade type connectors inside, which I presume are for power and ground, and then there's the much smaller pins for all the signaling. So this one actually went in quite well. Just popped in and then made sure it was seated on those 2 little sort of metal knobs, and then flick these nylon brackets or braces forward. And that's pretty much it. I'm going to leave the RAM in. I mean, to be really safe, what I'm worried about here is some bad voltage killing something. To be really safe, I could have taken all the RAM out except for one, but I'll leave the video card out for now because I'm really just going to be monitoring the serial port to see what the computer tells me on boot up. So no need to have a video card installed. So getting everything connected now that I'm going to need for initial power on. Make sure the power switch is off. We've got mains power plugged in. Up next, I'm going to connect a serial port cable. And I've got this with the right wiring RX to TX plugged into an old laptop with a serial port on it so that I can see what comes out. These Suns produce a lot of diag information out. And I'm not too worried about lightning shooting out of the keyboard port or anything like that. And the keyboards do have lights on some of the keys that flash in a certain sequence for post messages. So power on, and almost immediately we're starting to see the full run of diagnostic information sort of spool out of the serial port. And this is all looking great. This is all I expect to see. We can see it identifies CPU 0 here, and we can see it identifies in memory banks 0 through 3. It identifies our 16 megabytes of RAM in each one of those for a total of 64. So far so good. Great. We can see it starting to initialize the real-time clock and the NVRAM, which is all normal stuff. You can see it probes the SBus ports, sort of repeats itself here, doesn't find any SBus cards installed, and then starts going through the memory checks. And we can see that SPARCstation 10, keyboard present, ROM revision 2.12, 64 megs of memory installed. It's got an invalid Ethernet address and host ID, but then boom, we're at the OK prompt. And the OK prompt is essentially the BIOS prompt for what do you want to do? Do you want me to boot? Do you want to run some tests? Do you want to execute some forth code? So this is great. Totally successful initial boot up on with output through the serial port. So that's one boot down, one to go. Let's get that video card reinstalled here. We're going to just nuzzle it back in the SBus slots. And again, these can be fussy to get wiggled into the right orientation. So When you're doing this, just go slow, be careful, don't bend any pins, and you won't run into any problems. We can get these nylon brackets moved back into place, and then up next we can get some of the screws back into the chassis and get the video cable reconnected, and that's really all we need to do. The machine's basically ready to get booted up. I'm not expecting any problems here. The only way I'd really see some kind of a problem here would be if there was a problem with the frame buffer card, or I had done something with ESD while installing it, or something like that. So pretty straightforward process here for the initial boot. And we'll get that big 13W3 connector connected. I've got a broken old cable, but it still seems to work fine. And that's it. Power switch on, and drum roll, and we've got our graphics boot here. So system's basically ready to use. We can do whatever we want. We can reinstall the OS. We can do a net boot. We can boot off a CD-ROM into single user mode and do a password recovery off the disk that came with it. The sky's the limit. Anyway, thanks everyone for watching. I realize this is a pretty long video and pretty detailed, but I really wanted to sort of walk everyone through the process of what at least I've learned the hard way in many cases are some of the best practices for getting and doing an initial boot up of vintage hardware. And really it comes down to getting a lot of knowledge, finding a lot of the old documentation, and actually that's part of what I enjoy, is spending a bit of time online, going through archive.org, trying to find old documents, and it really helps me get a better understanding of these machines and really some of the amazing technological breakthroughs that were made by the companies that made them. And that's what kind of makes part of all this fun. Anyway, have a great week, everybody. Stay safe. I hope you've enjoyed it, and we'll see you soon.